Hello, dear students. Hello, dear parents. How are you? I hope that you are all fine today. This is Mrs. Rasad from Science Team at New Generation Language School. Today, we are going to talk about Lesson 2 on Unit 1 Wave Motion. So, first, look at this picture. When a drop of water falls on a surface of still water, a disturbance will be occurred. This disturbance will transfer from a drop to another on water surface, which appears in the form of uh, concentric circles. So these concentric circles are known as water waves. So the propagation of these circles on the water surface represents the wave motion. Perfect. First of all, we are going to talk about the wave. So the definition, it is a disturbance that propagates and transfers energy in the direction of propagation. Amazing. So now we are going to talk about the wave motion. It is a periodic motion produced as a result of the vibration of the medium particles at a certain moment and in a definite direction. So what about the line of the propagation? It is the direction of propagations of the wave. So, give reason. Sea beach's erosion is caused by the wave of water because the waves of water transfer the energy in the same direction of their propagation, then hitting the beaches strongly, leading to their erosion. What about the types of waves? Waves are classified according to number one, the direction of vibration of medium particles relative to the direction of wave propagation. And number two, the ability of wave to propagate and transfer energy. So first, it will classify it into number one, transverse waves, and number two, longitudinal waves. And the other side, electromagnetic waves and mechanical waves. So first, we are gonna make a comparison between transverse waves and longitudinal waves. So first, the definition. It is a disturbance in which the particles of the medium vibrate perpendicular to. If I said perpendicular to, so we have here in transverse waves to the direction of wave propagation. And on the other side, it is a disturbance in which the particles of the medium vibrate along the direction of wave propagation. So when I said along the direction of wave propagation, so we have here in the longitudinal wave. And formation. Transverse waves is formed from crests and troughs. So, crest it is the highest point of the particles of the medium in transverse waves, and trough it is the lowest point of the particles of the medium in the transverse waves. On the other side, the longitudinal waves is formed from the compression and rarefaction. So, first, compression it is the area in longitudinal wave at which the medium particles are of the highest density and pressure. And about rarefaction, it is the area in longitudinal waves at which the medium particles are of the lowest density and pressure. Don't forget that in the wave motion curve, the crest of the transverse wave is equivalent to the center of compression of longitudinal wave, and the trough of the transverse wave is equivalent to the center of refraction of longitudinal wave. What about the life application? Physiotherapy, tube, or jacuzzi. First, we are going to talk about the description. It is a tube where water moves in the form of circular moves. It's found in most health club. And what about the uses of the jacuzzi? Number one, it's used to treat sprains and cramps by using the hot water and nervous tension by using cold water. Second, electromagnetic and mechanical waves. So first, we are gonna make a comparison between them. They are waves which don't need a medium. So when I said don't need a medium to propagate, so we talked about here electromagnetic waves. And on the other side, they are waves which need a medium to propagate. So when I said which need a medium to propagate, so I'm speaking about the mechanical waves. So what about the types? They may be transverse waves or longitudinal wave, but here I'm talking about the mechanical waves. So there is something wrong here. The types of mechanical waves are transverse waves and longitudinal waves. And the types of transverse wave, the electromagnetic waves are transverse waves such as visible light, infrared waves, and radio waves. So there is something wrong here. The velocity of propagation. So first, the propagate by velocity equals 3 times 10 power 8 meter per second in vacuum. So it's constant. And on the other side, the propagate with a velocity is much less than the velocity of electromagnetic waves. Give reason. Radio waves are transverse electromagnetic waves. Give reason because they are transverse because the particles of the medium vibrate perpendicular to the direction of wave propagation, forming crests and troughs, and electromagnetic because they propagate through vacuum. And give reason. Sound waves are longitudinal mechanical waves because they are longitudinal because the particles of the medium vibrate along the direction of wave propagation, forming compression and rarefaction. And the mechanical because they need a medium to propagate through. Give reason. Hearing a thunder after seeing lightning, although they both happen at the same time. Because the light of lightning is electromagnetic waves while the sound of thunder is mechanical waves, whereas velocity of propagation of electromagnetic waves is much greater than the velocity of propagation of mechanical waves in air. Question number 2. We can't hear the sound of solar explosions, but we can see the light coming out from them. Because the sound is mechanical waves which can't propagate through vacuum, but the sun and the earth while the light between the sun and earth, while the light of electromagnetic waves which can propagate through vacuum. And what about the properties of wave motion? We have four types of properties. Number one, wavelength, wave amplitude, wave velocity, and finally